Right, a short summarized theory first, and then we'll get into the lab. VXLAN helps to extend the LAN, virtual extendable local area network. That's what VXLAN stands for. For example, in our topology here, this is in VLAN 10. This is in VLAN 10. This VLAN 10, if I connect like this, that's normal switching without any of these IP addresses. It will work, no doubt. By default they are switches, they will switch. But when we have more spine, right? When we have more and more spines like this, equal cost multipathing is what we expect. We expect some traffic to go this way, some traffic to go this way. But STP won't allow that to happen. Whenever we have redundant path, STP will come and block. So either you can use this one or this one. This one. One path will be allowed, all the rest of the path will be blocked. So even if you have another spine, that will also be blocked. So you will not be able to have that multipathing because of spanning tree protocol. Spanning tree protocol is good, but it prevents loop. Those things are nice, but the problem is we are losing a lot of our resource. Our devices are idle. Only one will be active, all the others are not really getting any traffic because they are blocked by STP. The other limitation is layer 2 VLAN only 12-bit. It can give you only 4095 VLANs. In that some are reserved. You can't use. So if you want to have more than 4000 VLANs, there is no option. In VXLAN, we have 24-bit. So you can have millions. And VXLAN, what it does is, it uses layer 3. In layer 3, you will not see STP coming into picture. How many number you may have as a spine doesn't matter. The redundant paths will never get blocked in layer 3. The reason is, each link is in different broadcast domain. Whereas in layer 2, all will be in same broadcast domain, so there is need for a block by STP to prevent loop. So what VXLAN does is to solve the limitation of STP, it uses layer 3 underlay and helps us to form a tunnel This tunnel is made up of IP, UDP. The port numbers, all the stuff we saw in the theory class. So it takes this layer 2 frame which is coming in VLAN 10, places it inside the tunnel so that layer 2 will get this encapsulation. This is the original layer 2 frame that is going out from here, is encapsulated with additional layer of IP UDP, which is the tunnel. So this IP is pointing towards this leaf from here. So the tunnel, that's what we call it as tunnel. So the packet gets delivered to this leaf with the help of the IP. And after going here, this area, this portion gets removed and the layer 2 frame is sent. So if you see the layer 2 protected here inside. These two computers, they work as if they are connected to one switch, a normal layer 2 switch. They both feel that they are connected to one single broadcast domain. The source MAC and the destination MAC, which is given here, never changes in the path. The original source MAC, the original destination MAC is preserved inside this encapsulation, which means they are in same layer 2 domain. See, if it is layer 3 in the path, the MAC address will change for every hop. That's networking fundamental. We know that. For every hop, the source and destination MAC address will change. But when it is layer 2, the source and MAC address will never change. There is no routing in between. Yes. Because of the tunnel, this computer see this as the next hop. They see that they are in same broadcast domain. Now, how about the forwarding path? There are two methods. One is increase replication using multicasting. The other one is increase replication using BGP. VXLAN without BGP is using multicasting, called increase replication using multicasting. No EVPN. The other one is using EVPN, which is BGP, MPBGP, control plane. Without BGP, it is only data plane. So we use the multicast address to identify the tunnel endpoint, and we keep flooding every time. But in EVPN, see, this is very important point. Focus. When this device comes, the MAC address is learned. Connected on E1/2, MAC address is learned. And this switch also knows that my another tunnel endpoint is this switch 2.2.2.2. So what it does, using BGP extended community MPBGP EVPN tunnel, it advertises as a unicast about this PC to the switch. The reason for going for EVPN is you don't need to flood all the time. Now this switch knows that VPC4 is connected to the device 1.1.1.1. Likewise, when this PVC packet comes, the MAC address is learned locally and advertised as a unicast BGP update to this switch, and this switch learns that VPC5, which is this one, is connected to 2.2.2.2 switch. Yes, the leaves are identified using their loopback address. We call that as VTAP. This is what actually EVPN provides you. Instead of flooding and learning, you have a unicast here. Flooding and learning is not good. It's not scalable. More you flood, more busy the fabric will become. This VXLAN will become very busy and it cannot support huge traffics. It's not scalable. It's not okay for big enterprises. That's why we go for EVPN. So when we have EVPN, BGP forms this tunnel for us. VXLAN forms tunnel for us. EVPN works with the tunnel. Through the tunnel, it advertises all the MAC address that it learns on one switch to the other tunnel endpoints. See, we got only 2 leaf here. In the real world, you may have 20 leaf. The update will go to all other 19 leaves if that same VLAN members present. If you would have done that layer 3 MPLS VPN, MPBGP layer 3 VPN, same concept. Route target of customer's A route goes only to customer A remote office. It won't go to B office. I proved you by pinging and all. Even though the address may be same, it won't go because of route distinguisher. And because of the target, it delivers only to the appropriate tunnel endpoint, not to all tunnel endpoint. Likewise, wherever VLAN 10 is, to them only this 10 VLAN members MAC address gets advertised, not to everyone. For that, EVPN uses route distinguisher and route target, same like layer 3 VPN. But the good news is, in MPLS layer 3 VPN, we used to configure the route target, route distinguisher, every number we have to give. In VXLAN EVPN, they're all auto. Route distinguisher numbers are auto generated and given. Route target numbers are auto generated and given. So you don't need to worry about it. It is very easy than MPLS layer 3 VPN. For those who have done MPLS layer 3 VPN, this is a piece of cake. Please ask me question before I take you to the command line. No questions? Please ask question, because we are going to get into command line. You are going to see all that you have seen so far.
No questions at this time.
Okay. Okay, so the concept wise, can I take that you're good? Everyone?
I'm tracking.
Yes. All right. Now, when you go to CLI, every command that I'm going to type should be a meaningful for you now. Every output that I show you should be helping you to understand what it is if you understand this theory. So, let's go. You see, this is Nexus switch. This is the best switch than any other Cisco device to do EVPN. But there are few things that you should know before you start this switch. Start using the switch. When you start this, you see, let me show you on Nexus 2. This Nexus 2 is simply turned on. See how it looks. This sometime, pop, discover, failed, yes or yes, skip, no. All these questions it will come. When you see this yes, skip, no, you just put yes. Alright? After you turn on, it will take like 10 minutes to 15 minutes to come here. Yeah. So you need to start like 15 minutes early. And then you put yes when this question is asked. I heard someone coming, but I couldn't see. Okay. So, you see, when I put yes, you will get this. Do you want to enforce security password standards? You say no. For the lab. For the lab, you don't need to have a encrypted strong password. You can have simple plain password. You say no here. And give password. I'm going to give admin itself as password. 2 times you have to give. Right, 1 minute. Let me. Okay. And then after you give the password, it asks this question. This is a very familiar question for you. Every router, whenever you log in for the first time, it'll ask, would you... I'm so sorry. Would you like to enter the basic configuration dialog? We always say no here. And now the system will be ready. You see, it asks the login, admin, and admin. Right? It is ready now. Likewise, NXOS2, I already gave yes to this question, and then it is asking the password thing, admin. Oh, this has become strong password. No problem. ADMIN@123. ADMIN@123. Okay. No here. So we got all the 3 consoles with us. You see, admin. So far what we have done is 1 minute. admin @123. So far we have just understood how to use this NXOS operating system in GNS3, nothing related to VXLAN. Now getting into the important portion of VXLAN, which if you forget this, you will not be able to see the commands that you want to see. What is that? In Nexus, we have to kickstart every service that you want. For example, I am going to run OSPF in between these three devices so that the VTAP address can be reachable to form tunnel. Okay, I'm going to run OSPF. You can use any protocol, OSPF or ISS. We are going to reach between these two addresses using some routing protocol, and I'm going to use OSPF. That's the underlay. Now, if I want OSPF, first I have to enable, otherwise you see a router OSPF. The command is not available. But when I say feature OSPF, after this, if I go and say router router, you see OSPF is available here. Previously when I put question mark it was not showing, but now it shows. So features you should enable. So I have enabled already what? Feature OSPF. We are also going to use EVPN BGP, so I have to say feature BGP. Right? Likewise, for VXLAN, we have to enable all these features. Interface VLANs, if you need SVI. In this lab, we don't need. But whenever you work with layer 2, layer 3, in the core or in the edge, we always need this. Network virtualization, that is for the tunnel. And then VN segment to VLAN. That's an important point. We were discussing that. I said we form a tunnel. We form a tunnel like this. So the tunnel has got the VNI, let's say 110. VNI is nothing but VXLAN network identification number, like VLAN number. Now what do we have here? VLAN 10. Now we are going to take VLAN 10 and map it to this and vice versa. Any traffic entering in this port, this VLAN 10 port, will be taken as the traffic of VNI 10010 and delivered to this 10010, and then it will be delivered to VLAN 10. The mapping. For that you need this command. Which command? VN segment to VLAN based. When a traffic from VLAN comes, it can be mapped to VNI. For that you need to put this command. This is the command you must type if you're going for EVPN. We may say like, I have put network virtualization overlay. Hey, that is only tunnel. That's not a control plane. In many documents, they forget to mention this line. This line. Because of that, we think that the device don't support EVPN. Now, after a long struggle in Access, you will come to this level. And then you will say router BGP 6500, and then you will say address family L2 VPN. All this will work. But when you ask for EVPN, it will say, now what EVPN? I don't know. And the documents also don't say that we need this command, and we are in an impression like, okay, I have VLAN to VNI. I have the tunnel. I have BGP itself I have enabled. Then I think that because we are tired after reaching this level, you're already tired. Digging deep and finding things, and then you think that, okay, this device won't support EVPN. Sometimes when you start this router, it will go to loader as if there is no image. So you go fix all those things and come, by the time it is 1.5 hours, 2 hours of struggle. And when you come here and see, after enabling feature BGP, when you don't see EVPN, what your mind will say, hey, this device don't support. And go to ChatGPT and ask, ChatGPT will also say, yeah, it is not supported. It will say that. After 2-3 tries, first it will say, yeah, it will support. And then if you say, this is what I'm saying, then it will say, no, it's not supported. ChatGPT will say it won't be supported, but it is supported. The only reason is this command is missing. Alright, so without fail, you put this command. It is not starting with feature. That's why many documents are missing this one line. Network virtualization overlay EVPN. Alright, NV overlay EVPN. Very important. After putting this, you go to BGP and see that command will be available. Address family L2 VPN. You see EVPN now. Last time when I put question mark, it was saying, who are you? What you are asking for? Why are you here? But this time it says, welcome to EVPN. You see? So, do not forget to put this command. And you're creating a virtual fabric, so you have to use this so that the tunneling environment gets created. Okay, so don't forget to put these commands. I'm going to copy this, and if I try to paste, you cannot paste. Why? This is a remote session, right? So if you want to paste, you need to jump to HTML console. HTML console. So I go to HTML console so that I can easily paste. No need to waste time typing. So it will open a window like this with your local putty. Alright, so done. I want to see, this is just a message. You can ignore this message. What is this message saying? you are enabling this feature network. This is very common in an EV environment. You don't need to take it too serious. It's just a message. It's not a error. Okay. So 1, 2, 3, 4, 5, 6 lines. 1, 2, 3, 4, 5, 6, 7. Okay. What happened? One is missing. 1, 2, 3, 4, 5, 6. OSPF, BGP, interface, VLAN, layer segment, EVPN. Okay, the last one, fabric. Oh, that is also here. So we have pasted all those 7 things. Likewise, I want to do it on the other devices before I forget. Okay, this is going to be the leaf 2. Enable config T. Okay, so we are going to now name it host name leaf 2. Sorry, write to memory won't work here. You need to say copy run start. Always say copy run start. Write to memory won't work. Write to memory will not work. Okay, so this is done with the features on. Here also this is called the spine. I'll say spine. And I got the other leaf already configured, everything. For testing, I configured the whole device. So I'm not going to touch the device. Nexus OS 1 is fully loaded. EVPN is done, OSPF is done, everything is done. We are going to do only on these 2 devices, and then this gets ready. Now this VPC, this is the computer from where we will generate some traffic. See, this is the IP address given to this PC, 192.168.10.1, which is written here, and this is 10.2. Same subnet it should be, right? 10.2. All right. Next. We'll focus on spine first, finish spine with IP address and OSPF, and then BGP. That's it there. There is no EVPN configuration needed in spine. Spine is just a BGP route reflector. Yes, very important, route reflector. I hope you remember the BGP class. The MAC addresses of this device will come here, but this won't give. Why? IBGP split horizon rule. So what do? We reflect, we say you can give it, you can reflect it to this client. So the MAC addresses of this, when it comes as a BGP update, EVPN update, it will be given down here. Similarly, the update going from here will be given down here when we say route reflector client 1111. So that spine is going to act as route reflector. So we should, without fail, put that route reflector command under EVPN. That's all involved in spine. Let me show you the configurations. You see, we give a loopback we give a loopback interface address. According to my topology, it should be 10.0.0.1. 10.0.0.1 with 32 masks. Without fail, run OSPF. IP router. This is the syntax. IP router OSPF process ID area 0. Right? You need to run OSPF, only then the reachability will be there to form tunnel using loopback to loopback 111122222. This is for spine. We are going to form loopback to loopback neighborship. And then the interfaces will be by default switch port. I remember when we were trying to do this lab on the other day, we were able to ping from this PC to this PC because by default they were all layer 2 switches. But now the ping won't happen. The reason is we are changing it as layer 3. What does that no SW means? No switch port. No switch port. Making it as layer 3 port. Bringing the interface up. Giving the IP address. Enabling OSPF. Making it as point-to-point. Why? So that there is no need for a DR-BDR election. Okay? You see this is 12.2/30. 12.2/30. This is 12.6. 10.0.12.6/30. Alright, OSPF route ready. By default it will take the loopback interface. If you want you can give it manually. Try to put it in the top. Okay, so is there any question so far in the configuration? Please ask. We are enabling OSPF under the loopback and physical interface with the IP address configured on OSPF. Sorry, on the interfaces. We are making it as network point-to-point so that there won't be DR-BDR election. Is there any question in this configuration? Can I paste this? No questions. Okay. I'm going to go to spine now. This leaf tool. This is spine. I'm just going to paste it. You want me to type it or is that okay if I paste it? Please someone answer. Your comfort level, I do not know. If you are familiar with this command, you will think that pasting is okay. If you are new to these commands, you may like me to type every command. What do you say? Do you want me to type every command or after explaining I'll just paste it?
Pasting is fine.
Pasting is fine with you. Alright. So this is OSPF followed by interfaces, IP address, OSPF enabled under the interface, the network type under the interface. Done. Next. The underlay routing protocol is done. Next is for the overlay BGP. We are using Autonomous System 6500. This router ID is a good practice. Even if you don't give, it will take the loopback interface address router ID. You see, under the loopback interface, where is the loopback interface? Here. On the loopback interface, I have given this address. So it's the same address BGP is taking as router ID. Even if you don't give, it will take, but it's a good practice to give manually. Secondly, enable the L2 EVPN process. First you enable the process globally under BGP. This line will come automatically. You no need to type this command. Alright, but after you get into BGP, first thing is you start the process. And then you tell that I have two neighbors. Who are those neighbors? They are two spines. Sorry, there are two leaves. For the spine, we have two leaves. The spine, we are in spine right now. They have two leaves, 1111 and 2222. You see, 1111 and 2222. We are mentioning that these two leaves are my IBGP neighbors. See, same autonomous system number. If you have same autonomous system number, what does that mean? The neighbors are in same BGP. 2222. Right? You know the command update source loopback 0. Why? Because we are going to form neighbor using loopback. So the BGP update should go from the loopback, only then the routers will accept each other. And then you are going to say this neighbor is a member of EVPN. Understand? This is globally enabling the process. This is under each neighbor. You are saying whether this neighbor is a member of EVPN or not. You have to say this under each neighbor. The send community both, it will come automatically. You no need to say that. Even in layer 2 MPLS, layer 3 MPLS VPN, this command comes automatically. We never said this. Maybe I will do this one manually instead of cutting and pasting. You know, because you may be new to this particular commands. You see, we say router BGP, route BGP 65,000, and then we have to say address family. Layer 2 VPN, EVPN. This is to enable, this is to start the process and then come out of it. The process is started. Neighbor 1.1.1.1 is my neighbor. In one single line you can say remote AS like you used to say in router, or you can put it in second line also. It is your wish. In routers we used to type like this in normal iOS router in one line. That is also allowed. Or you can also type like this in two steps. Neighbor separate, remote AS separate. And then update source is loopback 0. And then this neighbor belong to address family, L2 VPN, EVPN. Okay, one neighbor is done. Now let me go to next neighbor. Neighbor 2.2.2.2 remote AS 6500 update source loopback 0 address family L2 VPN EVPN. You see, I did not type those send community both all the stories. It will come automatically. Copy, run, start. Now let us see how it looks. Show running BGP. You see, address family, and then router neighbors, update source loopback 0, address family L2 VPN. What is missing is in the notepad also it is missing. These need to be configured as route reflector client. That is missing. These two neighbors, spine should reflect route to these two neighbors. That's how I should say. The spine should reflect routes to these two neighbors. So I should say route reflector client under each neighbor. Like I have said, each neighbor a member of L2 EVPN, I also need to say this neighbor is one of our client. Route address family, go under address family, L2 VPN, EVPN, because for EVPN only you are a route reflector client. So you say now here route reflector client. This command is missing in Notepad. So now you understand who can use Notepad. Not the beginners, not the learners. Those who already know very well things clearly, they can start using Notepad. Some people will start doing Notepad work right from the beginning days. Then you will miss a lot of things and you will waste a lot of time in troubleshooting. You see, I can very well say that hey, this is missing here because I know the concepts. So we are using Notepad only to reduce our job, not to finish the lab fast. Finished lab is not the target. Learning is what our target is. So don't use Notepad unless you know things well. Exit. We got another neighbor 2.2.2.2. Address family L2 VPN, EVPN, and then route reflector client. To be on safer side, I also want to put this command send community both because I did not see that in that. Usually it comes automatically. I did not see in the running configuration, so I am doing it. Why to take risk wasting time? What's wrong in doing that? We know what that command means. That command means that BGP can use that extended community to carry the route targets. Yeah, the route target values are carried using the extended community. So we say send, not here, address family L2 VPN, EVPN, route reflector client. Also globally, after saying address family L2 VPN, EVPN, I'm going to say retain route target all because route targets will be coming. This command also should come automatically. In some versions it looks like it don't come, so I put that command, and then we say copy run start. Okay, I want to make sure that all the commands are in place. So show run BGP. You see, retain route targets all. Route reflector client looks good. Route reflector client good, looks good. Don't worry about this. Oh, I have not put here. That's why it has become 2 times there. Okay, no problem. I can put it again. I put for the same neighbor twice, so it shows 2 times there. Route reflector client. See, that's good, important. That's good to verify before we move on to the next router. Copy run start. show run BGP. See how easy it is, only this much. Why it is not under that one? That is okay. If it is needed, we'll come and troubleshoot later. So I gave to 1111, right? Yes. Yes. That's okay. So next is the next thing is leaf. How easy it is. You see, the spine is already done. What you have done here extra, instead of in layer 3 VPN we used to say VPN v4. Here we are going to say L2 VPN EVPN. And this is just a forwarder, so you no need to configure any other EVPN like route target and route distinguisher. This is not tunnel endpoint. This is a transit. Only on the tunnel endpoint, we need to map this VLAN to VNI. We need to say that BGP will be giving all the routes. Those story comes only here on the tunnel endpoints, not on this router. This router is simply to receive from EVPN and give it to the other EVPN neighbor. So the configuration of the spine is only this much, very easy. And on router 1 I have already configured all this, so I'm skipping. I'll explain router 2. It's the same configuration on router 1 and router 2. Router 2 is another leaf like router 1, isn't it? So there is no extra configuration. If you understand router 1, leaf 1, leaf 2 configuration is also similar because both are leaf. Okay, so I'm going to NXOS 2 now, which is not configured. We have only the host name. Okay, we got only the host name configured in this. Let us go through the notepad once to understand what is needed. IP address is needed. What is missing here is OSPF. So let me take this and put it on top. And then under the interface you must run OSPF because they have to negotiate and bring the tunnel. So we say IP router OSPF1 area 0. This is the syntax for Nexus. You cannot put network command under OSPF. Those commands won't support. All right. And this is to make the interface as a layer 3 interface. We give IP address, we say point to point, we enable OSPF. Similarly here. No, not similarly here. This is very important. Listen. This E1/2 is not a routed port. E1/2 is not a routed port. It is facing down. See the diagram? E1/2 is facing down. This is a member of VLAN 10. So don't say no switch port. It is a switch port. It should be a switch port. And switch port mode access, VLAN 10, no shutdown. This is the routed port. Routed port E1/1. You see, E1/1 is connecting up. This is where you need OSPF. Right, now I'm going to paste these things to that switch. So what we have done is the layer 3 configuration on E1/1 and layer 2 configuration on E1/2. I'm in the wrong mode. I need to say config T before I paste. Now paste. Yeah, done. So the basic underlay routing protocol is over. Now we need to do the overlay. You know the autonomous system number, router BGP 6500, and then we say address family L2VPN EVPN, and then what we need to say the neighbor, then we need to say the autonomous system. These are all same command. You don't need to put the route reflector command in this router because this is not a spine. These things are known to you. So let me come out of this and then say neighbor. The spine's address is 10.0.0.1. That's the loopback address of spine. That spine belongs to remote ASM 65,000. And then whenever I speak to the spine, I have to use the source loopback. And then this belongs to address family L2VPN EVPN. Send the community both. Done. Exit. So this part also comfortable. I hope you will be comfortable because you have seen this in spine with more commands like route reflector, etc. So let me copy this up to here. Copy. It works here. No need to put do command. All right. So what is next coming is totally VXLAN and EVPN. This is VXLAN. VXLAN needs a tunnel interface. This is the tunnel interface. You remember when you do GRE tunnel, what you used to say? Source, tunnel source. So here also we say. And we used to say tunnel mode GRE or MGRE if it is DMVPN. Here we are saying host reachability protocol, BGP, not multicast, BGP. Okay. So let me put these commands, which you know now what it is, on the command line. The network virtualization edge is the name of the tunnel interface, network virtualization edge. And you're bringing the interface up and you say this interface will use the loopback tunnel we want to form between loopbacks, right? VTAP address. So loopback. And then host reachability protocol, BGP. Next is, this is the VNI number equal to VXLAN. So we have to say this. We need to say that this interface, the tunnel NVE1, will carry the traffic of VNI 110, means 10,010. Can be any number. I'm using 10010. And then all the updates coming to this VNI need to be carried by BGP. So I say whatever is coming in Greece, you replicate using the protocol BGP, not multicasting, not flooding, using BGP. I hope up to here you are comfortable. I repeat, we need a tunnel interface. We don't use tunnel 0, we call it as NVE, network virtualization edge. bringing the interface, saying that it needs to use that loopback interface as a source, tunnel source. Host reachability is using BGP. That's how you reach the other tunnel endpoint. Negotiate, and then it has to take all the traffic coming for this particular VNI and give it to BGP, so that BGP can carry to remote leaves, remote IBGP members. Now this is the mapping that you do between VLAN to VNI. So first you create VLAN. You can create VLAN here itself, VLAN 10. So first you create VLAN 10. And then we say VN segment 100010. This warning also you can ignore. This is very common in EV environment. Next. What is next is the EVPN, the control plane. So easy. Only this much. You no need to worry about route target, route distinguisher, all the stuff. Everything is auto, you see. Import is auto, export is auto, route distinguisher auto. You are saying this EVPN should run for this 100 traffic. To carry the updates, route distinguisher. It needs to give a unique route distinguisher for each VNI. That's called route distinguisher. And it needs to give unique route target so that it can be exported and imported between the tunnel endpoints. Okay, so this also I am pasting. That's all actually. VXLAN EVPN is only this much. If you understand and do, it will be easy. Now let's verify and show. I will show you things. Before that I'll say copy, run start. First thing what I want to verify is the BGP. I'll go to the spine and see whether I have two neighbors. Wait a minute. Before that, let me go and bring this command line here. This is already configured. This switch is already configured. Admin. Okay. This is already configured. I want to first verify the underlay. So I'll go to spine. Spine is NXOS 3, this one, and see how many neighbors I can see. Show L2VP. No. Let's go with BGP command. Show BGP L2VPN EVPN summary. Easy. If you know layer 3 BGP, you will also know this one. Show BGP VPN v4 unicast summary. That's what we used to type in layer 3 VPN. Here we are saying show BGP L2VPN EVPN summary. It shows that it has learned two neighbors. And you see it has already learned 1 MAC address. But just 1 MAC address is not enough. Still it did not learn the MAC address of the connected computers. It has only learned the MAC address of leaves. How do I know that? Cut the summary and hit enter. Yeah, I don't see any MAC address. I see only two leaf identification with the route targets and route distinguishers. Okay, so far no MAC address is learned. Do you see any MAC address here? No. You don't see any MAC address. Now, BGP is good, which means OSPF is also good. If not, this is not possible. Listen, final verification. But before that, I want to show you the commands. This I no need to verify. The reason is BGP itself has come up. Without OSPF, it's not possible to get BGP. This command I have showed you. This is no need of a route. Just put this. This command I shown you to see the routes. Now let us type this command, show NVE peer. I want to see whether this has formed a peer with this. Go to NXOS1 and type show NVE peer. Not available. We'll generate some traffic, then we will see. Network virtualization. Let's see this one. Show NVE, NVI. Show NVE, NVI, network virtualization interface. We need to give the ID number. VNI. We need to give the VNI number, or you can also say all. Wow, it looks good. You see, this is the VNI we have configured. We said that this VNI will use this tunnel interface, and it won't do flooding or multicast. It will do unicast using BGP, and it is up the control plane mode. You see, CP. EVPN is up. It's going to transport all the VLAN 10 traffic over this. This is a very nice output. You get everything in one place. You know for which VLAN, which VNI is working. See, the same tunnel interface will have another VNI 20 for VLAN 20. All those informations you can see here. Next, show MAC address table. Wonderful command. Show MAC address table. As of now, I am not seeing any connected device MAC address. This is the MAC address of the local interface, Ethernet 1/2. This is not the MAC address of the computer which I have connected. This is not. This computer's MAC address is still not learned. Let me go here and check whether it is learned or not. We need to generate traffic, only then it can learn. But simply I want to check what. Show MAC. Okay, this also has not learned. Right? So we are going to generate traffic from A to B. Then you will see this MAC address learned and given. This MAC address learned here, given to this guy. This will reflect to this guy. And now this guy knows the MAC address of the remote PC. Similarly, this MAC address goes here. This guy takes it, reflects it. And now you can have the reachability over the tunnel. Tunnel is ready. Only thing is I have to ping and verify. Let's see this after just 5 minutes break. We are going to now test it. When I tested this in my lab, this is your lab which I am using right now, the same lab which you are having. But when I tested in my lab, it was not pinging. But everything was happening, like MAC address was learning from here to here, here to here. BGP was taking it and giving from here to here and as well as here to here. Everything is happening. If the ping doesn't happen, it is because of the VPC. Alright, so let's see how it works here. If it is not pinging, definitely it is VPC. And I'm going to show you all other outputs will be good. Ping may not happen, but all the MAC address learning, everything will be happening. It's ICMP in the environment. Now, before pinging, you see this is the condition of your MAC table. But after I ping, I'm going to ping the remote device. Right, before I ping, I want to make sure everyone is in sync. What is this? Let me refresh this. Maybe HTML console don't work. No problem. We'll switch on to the other console. Something is wrong with the PC. I'll shut down the PC and I'll on it. What about the router? Okay, the leaf is functioning good. I want to bring leaf 2 also. Leaf 2. Good. And then the transit, the spine. Okay, so before I ping, this is the important place because the ping may not happen, but this confirmation you need. Before I ping, show BGP, L2 VPN, EVPN. You are not seeing, oh, I already see one MAC address. One device because I just turned on this, it has sent gratitude ARP, GARP. It says, hey, I'm here. You see, earlier we were seeing only this 1111 and 2222. But now you are seeing a new address coming from where? Coming from the source 1111. This is the route distinguisher. So this is the MAC address class. Listen, this is the MAC address of this PC. I'm going to prove that. Go to the PC. And type show. And do you see MAC address here? Okay, you see the last number in the linked local address. 684C. Go here. 684C. Okay? I hope you understood. 66684C. You will see there. 66684C. Alright? So, your EVPN is working. Let's see the MAC address which is learned here, whether it has come down here or not. NXOS2. Same command. Show BGP, L2 VPN, EVPN. Bam bam. Nice. You see. This is the MAC address coming from the remote 1111. This is the MAC address of okay. This is learned from there. Okay. Now let us go and invoke this guy. This guy is dead. We'll bring him live. Shut down. Bring him back. So now I'm expecting in spine another MAC address. Because whenever you newly add one computer, even before you ping, they talk. G-ARP. Alright, it's not normal ARP. Normal ARP is when you try pinging. You might have learned this concept, gratitude ARP in VRRP, HSRP, all high availability concepts. So let's now try spine. Do you see any new MAC address? Yes, it says I am seeing this MAC address from this guy. So 684D is the MAC address of this computer. Let me show you that. Show. You see? 684D exactly. There's no more verification really needed for a technical guy. Don't wait for the ping to happen. That is simulator limitations. Now let us try pinging. What if it's a lucky this environment, my environment didn't support. I'm going to ping now the remote. Remote is 192.168.10.2. This is the problem. See, this is the problem. So the ping won't happen, but these things are all working fine. That's because of that simulator. No, it's not a real Windows machine. You need to understand that. This is not a real Windows machine. Here. Show L2 VPN. Show BGP. L2 VPN. EVPN. You see, it says this is local. This is local. Let's go to the VPC5 and try pinging. You will learn the MAC address here. Ping 192.168.10.1. So this MAC address will be learned from here to this. This already we saw the 2 MAC address. I want to see whether this MAC address is reflected down here, so I go here first and check. Do you learn? I know, still this has not learned. The reflection is not happening towards 1111. So I'm going to R3 to check BGP. I know that there was something not normal under BGP in spine. Show run BGP. You see this router reflector client. Okay, the extended communities are not showing there. Let me go fix that. Router BGP neighbor this. Under this, send community both. Copy, run, start. Now, so it was that mistake. Now let us go and type show run and check whether we have everything in place. Okay. It sounds good. I can see extended. Okay, now I'm expecting on NOXOS. I was not seeing the other MAC address, but now I should see. Look at this. You got both the MAC address. This is the MAC address from the remote device 2222. This is the MAC address local 1111. Now, at least now will it ping? See, ping and all I don't really expect. Again, I'm saying, if you are lucky, if the simulator has got some magic, it may ping. But in the real device, it will ping. See, I know. Because I tested this in 2 other platforms, it was not pinging. All the other things are functioning well. The MAC address distribution, everything is happening very well. I just showed you here, as well as on NXOS2. You can see both the MAC addresses are reflecting. Yeah. Both the MAC addresses are reflecting here. But still, if you're not pinging, it's not the problem with the EVPN, it's the problem with the operating system in the VPC. It's not accepting that packet. Right? Any question on VXLAN EVPN configuration? Today it's EVPN, VXLAN EVPN configuration class. Was it easy to understand or difficult? Have you learnt it? Is there any question? Are you comfortable?
I'm tracking it.
Thank you. So, I have given my best, almost 15 days. I hope this will contribute in some good manner for your future. With prayer, we did this, and you have also put your effort, and I know God is there in control. He reigns. The righteous God will do always good to the righteous people. The righteous God does good things to righteous people. He will do it to you. He will bless you more and more, and He will keep you safe. Thank you so much. Good luck. Take care. Bye-bye.
Thanks, Aaron.
Thank you, sir.
Thank you, sir.
Welcome. Welcome.